Hello folks, so let's proceed ahead with our Rust series where we left off. And in this video, we will be discussing about generics. Now in the Rust book, this will be the first section of the 10th chapter, and here you can read about generic data types. And you can also find my blog in Hashnote about generics in Rust. So let's try to understand what are generics. So generics are basically how we can handle multiple data types effectively. Now, what do I mean by that is something we will see in our VS Code by writing some program rather than talking, as always. Now, I know it's a cliche, but we will be writing a program to compare two values. Now, let me remove the hello world because it's definitely not required. And here, first of all, let's say I want a function that will compare two integer values. So what I will do is, let's say I am storing the result of the function in this result variable. Let me name it result. And let's say I have one function. Let's say in the function is compare int, and inside this function I will pass two values, let's say 5 and 10, which is definitely unequal. And now let's say we got our result that is false, and then we want to basically print out our results. So I will do println, and inside I will write result. Now this is something that we are all familiar with. Now let's say I want to compare two decimal values also. Now, in that case, what will happen is it's difficult to pass the same values inside our comparint. Why? We will see by writing this program first. So what we have to do is we will declare another program. Let me name it comparint because that is the name by which we are calling the function in the main. So it's definitely of this name only. And then we have to specify which are the parameters this function will be accepting. So first of all, we know that the function will be accepting two values. So value 1, and then we also have to give the type. So let me give the type as int32. Sorry, it should be i32 and not int32. And then val2, this should be i32. And what is the result? The result will be a boolean. It's either true or false. And here I will write val1 equals to val2. Now it is quite clear from the definition of the function that this function will only be accepting integer values, that of specifically i32 type. So it is not possible to, let's say, pass something of like which is not integer, like which is a float, for example 5.5 and 10.2. So if we try to run, and let's say let's change the name also, it should be res dc res tech. Okay, so now let me just save, and we are already getting some kind of errors. So arguments to this function are incorrect, and expected is i32 and found a floating point. So we can find the issue. So what happens if I simply remove these things, and let me make it val2. So now we have a issue over here only, and that is if this is a self type, because it is a parameter named self. So basically either we have error here or there, but we will be having errors. Now there are only two logical ways to solve this problem, and the first way is let me just give the old values only. And for our decimal, what we will do is we will simply write another function. Let me name this function as compare dec, and here I will simply copy all of these things, and after copying, our errors will be mostly gone because this function will be compare dec, and the values it will be accepting are float. So now there should be no issues. So let me simply run once again. Why is it writing? Perhaps you intended to use this type. Yeah, that is correct, and that is in Rust we don't write float, we write f32 or f64. Yeah, now there will be no issues. So let me simply do a cargo run once again, and it's building our project, and we have false and false, and that is because the values are incorrect. If I make it 5.5, let's say, we will be having false and true. So cargo run once again, and we have false and true. So this thing works, and we can also add other types here also, for example a string slice or something else. So this is a basic idea how we can solve a problem like this, so where we have to compare two values. But as you can see, this is quite repetitive. So this is where generics come into the picture, where we can write only one function to do all of these things. So how can we do the same using generics? So what I will do is I will write another function, and this will be a generic function, which will be defined by writing t in angular brackets. This means that the function accepts t, and we will be basically using variables of the type t. And what is the variable that will be defined by the same process, but instead of i32 or f32 or anything else, we will write t. That means the value is of the type t, and it should be value 1 because we have 2. So value 1, ah, so many typos. Value 2, and the return type will once again be bool, that is either true or false. And here what we need to pass is value 1 equals to value 2. Actually, this will throw an error, but let me first show you what is the error. And we already have some red squiggly lines here. Binary operation equals to cannot be applied to type t. I will simply ignore this and do a cargo run, and we will get the same thing here also. So binary operation equals to cannot be applied to type t, the same thing. Consider restricting type parameter t to partially q. So what does this mean? It means that the Rust compiler doesn't know whether value 1 and value 2 can be compared or not. I mean, yes, they are of the same type t, but it is possible that they still cannot be compared. So in this case, we are getting this error. And how can we ensure that they can be compared? So in Rust, there is something called traits, and we can use this trait called partial EQ. So I will write where t is, t has this trait that is called partial EQ. So I will write t colon partial EQ. Now, what are traits and how come this is valid now? We will discuss all of these things when we are discussing about traits in detail. For now, you can simply understand that when t has the trait partial EQ, it means that the value of t can be compared. And so we are comparing value 1 and value 2. And now in our main function, I will simply remove the int and dec part because we can now simply use the compare function. And now let me do clear and do a cargo run once again. And we will have the same results, and that is false and true. Now here we can also add something else. So let me add raise str, and let's say we want to compare two strings, string slices to be more specific. So let's say I want to compare hello and world, which is definitely unequal. And so we are expecting the appropriate results. And let me do raise str, and I think there is one extra layer of parenthesis. So now this is good. If I do a cargo run now, we should be getting false. So we are getting false, so this is correct. And if I do a hello, hello, we should be getting a true now. No surprises there. So this is fine. So what essentially Genrix is doing is it is basically consolidating three functions into one in this specific example. And in many other examples, like it is improving efficiency by a lot. So this is how generics are quite helpful. Now in this specific case, now let me also remove these two functions because it's not really required. Now in this case, we are only using generic values of the type t, but we can also use generic values of multiple types. So let me write another function to give an example. So let's say we want to compare two types are equal or not. So I will write a function called r types equal. So this function will be taking two generic types, t and u, and the output will be a bool once again, because we essentially want true or false, the types are equal or unequal. Now, in this case, we are not passing any values, so there is no specific values that are required. We only need the type, so t and u is fine. And we will also specify that t has a static lifetime, and so has u. Now, what are lifetimes? So we will discuss in detail in the video about lifetimes. For now, just bear with me for some time. Now we want to compare types. So how can we compare types? We can compare it by writing something like this. Standard any type ID of, and then what is my type? So T in this case, and we are basically trying to compare it with our U. So U here. So this is our function, and I think there is some issues with this. Use parentheses to call these things. And that is actually correct because we are actually using functions. So there should be one parenthesis at the end. Okay, now all good. Now in our main function, I want to basically call this function also. So let me write raise type, and this raise type will call this function r types equal. And here we want to basically pass two types, and we are not really passing any values. So the types will be, let's say, i32 and i32. This is the first one, and we are invoking the function also. And then we are storing the value in the res type, and then let me simply print it out. Now let me do a cargo run, and we should be getting true, and we are getting true. And now let me compare with U32, and now the first value should be false, and let's see, we have false. So that means both of our functions compare and are types equal are working perfectly fine. And we are getting a brief idea like how generics work and do stuff. Now that's all for this video, I would say. And in the next video, we will be discussing about the option type, where we will be revisiting our enums as well as our generics, because option is quite special kind of enum where we are also using generics to do stuff, you can say. So that's all for this video. And if you have learned something new in this video, make sure to like, share, and subscribe. It gives me a lot of motivation to create a lot more videos like this. And I will see you next time with a video on options.